Well, it's a peer-to-peer discussion, so you're going to hear from both of us. And we've been talking already for an hour this morning, so we thought it'd be good to let you all in on the conversation we're having. So we'll continue a great discussion we've already started. Maybe we just start with a good morning, DLD. Can we hear that back from you all?
Good morning, DLD.
Yeah, okay. So we'll get the energy going in the session here. And you know, we've been having a great conversation, and you know, the title, I guess, is a giveaway because it's titled Quantum and AI. But maybe a softball question to start with, Grazia, is you know, as you look out, Airbus is doing amazing things across so many different areas. What do you think is the most transformational technology that you're facing as you look strategically across Airbus, and why?
Yes, thanks, Paul. Well, definitely, aerospace has always been about overcoming physical limits. And we see fresh challenges coming at us. Well, the demand for air travel is growing at nearly twice the pace of economy. And we know that like every 15 years, the number of passengers, the number of aircraft double. Literally. So that could take us around 2037 to have more than 50,000 aircraft flying. To be able to master this growth, we need to deeply transform our industry. That's why we're looking into several transformational technologies. We need to develop, for instance, electrical hybrid propulsion to cut down on fuel, to cut down on noise, on emissions. We need to go for more and more autonomy fueled by artificial intelligence and connectivity to ease congestion of airspace and regulate and optimize air traffic management, for instance, especially at airports. We need to investigate and research multifunctional materials. But mostly, we need to do all this at the same time, coherently and concurrently, because we know very often disruptive innovation comes at, when different technologies converge and intersect, right? Yeah. And in this sense, quantum technologies will be definitely a transformational quantum leap for the aviation industry. Why that? Because, simply put, while quantum computers process an unparalleled amount of data at unparalleled speed, and that will enable us to tackle the typical issues we face in the industry in terms of complex optimization problems where we have different parameters, different requirements, different disciplines, having to converge into an optimum, right? So that's absolutely where we're looking into quantum technologies, computing, communication, sensing, as really a transformational technology. And we're doing some real cutting-edge research in that sense, and already have some very tangible application cases.
Maybe dive into that, because we heard about quantum earlier today, and you talked a little bit about all this innovation, different areas you're seeing in the business. Maybe make it real and concrete with some of the applications of quantum that you see really being transformational at Airbus.
Yeah, beyond the science of it. So just to make an example, trajectory optimization, especially on long-haul flights, like when you're flying from Paris to New York, if you want to keep it as cheap as possible, you can choose to optimize the time in the air, the flight time, or to cut down on fuel, looking for ideal meteorological conditions, so having tailwind the whole time, right? Or you can do both at the same time, optimizing the two equations, and ideally, for instance, at each single point of your journey, for instance, across the whole Atlantic, right? So this is the example of a really epical type of problem statement which quantum computers can solve in a matter of seconds, whereas classical computers take days. Another example, satellites, mission optimization. We have a whole fleet of Earth observation satellites out there, tasked via customer request to really capture images of the globe, different positions at different points in time, with different recurrence intervals, different sizes, and classical computers manage the mapping, the positioning of these satellites, and the tasking, with some physical limits, right? Because satellites can take just one picture at a time and need to reorient themselves each time in order to satisfy another customer request. And this is where we're experimenting with the DLR, the German Research Institute, and to see how quantum systems can really enable, thanks to superposition, different tasks to be simultaneously and concurrently fulfilled by such a system. QKD, quantum key distribution, applied to drones, right? So one of the limitations and challenges into industrial application of drones is really the security of the command, control, and communications link.
Sure.
And so we're studying to provide a low weight and high speed solution to enable quantum encryption and therefore a safe link. These are just a few of the examples we're working on. And what about you? Where do you see transformation? What does quantum mean for Accenture?
Yeah, no, it's a good question. And I'll deal kind of more with the applications, as you talked about. I'd start off by saying that I like to think I've been right about a lot of things in my career. I was wrong about quantum about 6 years ago. In 2012, I actually de-emphasized and removed some quantum research from the research we were doing, because at the time I looked at it and said that's going to be further off. We didn't see some of the signs of it really commercializing fast enough. And 2 years later, I put it back on and accelerated because we saw some of the signs increasing. So for the last 5+ years, we've been really focusing on quantum and believe there's a lot of potential. The way I look at it is in the broader context of what's happening with computing. The transistor, the patent on the transistor was issued 70 years ago in December. Roughly 70 years ago last month was the patent on the transistor, which has defined semiconductors in the von Neumann type of architecture that defines every type of computing, including cloud computing today. And simply put, you kind of said this, simply put, the current classical computing cannot support where the world is going. The volumes of data and the compute needs that we face going forward can't be supported with classical computing. So we believe quantum computing is part of the answer, as well as other things like neuromorphic computing, new memory-driven compute, new types of architectures, in addition to everything we see happening with AI, like GPU processing and ASICs and FPGAs, new forms of processors. So we're moving into this new world where it won't be defined by the traditional semiconductor, silicon-based transistor architecture that we've had in the past. And I think every organization needs to look at these new forms of computing. Quantum stands to be the most powerful. And we're looking at quantum applications in a number of areas. You talked about some great ones. Quantum key distribution, I think, is a great issue, or great area in terms of secure communications, which is one interesting area. Another area we're looking at is security. Shor's algorithm, some may have heard about from Peter Shor, showed how quantum computing can break all RSA-based encryption techniques, which is the foundation of our current security in financial transactions. So quantum stands to break our current security model. So quantum safe encryption is a field we're doing a lot of work on. And I think this is something that will conclude relatively soon, has a Y2K-like impact where we need to update traditional security to be quantum safe, and that's going to be a pressure for every organization. Yeah. So we're doing work around that. And then there's the industry applications, portfolio optimization in banking, supply chain in transportation companies. We're doing some work around quantum algorithms. Areas like grid optimization in utility companies. And one of the things we announced last year was work we did with Biogen in the life sciences industry for molecular compound analysis and solving optimization problems around matching disease characteristics with molecular compound physical characteristics in ways that would have taken years of computing power with traditional architectures could be done in seconds, literally, with quantum computing. And those are some of the exciting applications we see.
And well, definitely that's something for tomorrow and the day after tomorrow. But today we already see artificial intelligence impacting very many different industries. How do you see that happening, and how do you think it will impact the future work?
AI, yeah. Well, it's kind of related. So quantum. So why are quantum and AI in the same discussion? It's a lot of AI is math-based, and quantum is a math-oriented solution to problems. And when you look at certain machine learning techniques, quantum actually comes into play in terms of accelerating some of the machine learning into AI. But AI is kind of here today. I'm not sure how to use the word commodity. Steffi said commodity. It's just common and becoming more commonplace. We just did a survey highlighting that, which said that 49% of organizations are either widely deploying or significantly deploying AI in their organizations, 49%. Another 40% of organizations are either piloting seriously or planning, and 8% of organizations are doing nothing. So only 8% of companies are doing nothing with AI. The rest are doing something. And AI, I believe, is one of the biggest disruptions we'll see. Quantum is going to completely change the notion of how we compute and how we solve problems. AI will completely change the relationship between people and technology. And that's why I like to call AI, instead of artificial intelligence, I like to call it collaborative intelligence, because it's taking the best intelligence and capability of people, combining it with AI capability that allows people to do things more effectively. So we wrote about this a lot in the book that Steffi referred to. We believe 90% of jobs will change significantly because of AI. 50% of jobs will be transformed in the next 5 years. And so the challenge for organizations is to master the technology. And there's tremendous applications we could talk about of AI being applied today to drive a lot of business value, new business models. But the challenge also is to reskill people fast enough for these new jobs and new roles, because the message I'll end with on this is you're not going to find a job market of AI-ready people specialized to your industry. The only way that you'll find the right AI-enabled workers for your organization is to develop them yourselves, because these jobs are changing so fast that if you don't develop them, nobody will, and you'll be left behind. So learning and reskilling is part of the core competitive differentiation for companies with AI, in addition to mastering the technology. That's something we're very focused on.
Yeah, we absolutely share that kind of challenge in the aviation industry as well, where we really see that artificial intelligence is impacting and redefining all areas of our business. So leveraging on artificial intelligence means having massive amount of data, some very smart algorithms, and sound business models to bring value out of that. And what we're observing is that aerospace is really transforming, going from a sort of nuts and bolts business to really one of the most data-rich and data-dependent businesses out there. Just think, one of our latest aircraft, so the A350, has 250,000 sensors on board.
On one plane.
On one plane, harvesting data, which then can be analyzed, combined, to really draw value for our customers. And that's why in 2017, we've rolled out Skywise. So that's the first aviation open digital platform crunching this enormous amount of data. We're talking about 3.5 petabytes. We have 3,000 connected aircraft for the time being, really drawing valuable information to our customers in sense, for instance, of predictive maintenance, right? But artificial intelligence has many other applications, typically on autonomy, right? So that's what we are looking into, artificial intelligence, in order to be able to free up pilots from mundane, routine tasks.
My next flight, I'm not going to have a pilot.
Well, maybe you'll have only one instead of two. You know, we're taking it step by step and really see the potential of going to a single pilot operations type of model in the near future before we go to fully autonomous aircraft. We have urban air mobility fueled by artificial intelligence. We see it in space. We have in the international space stations right now, we see Simon flying. It's a sort of a medical ball-sized 5-kilogram assistant to the astronauts based on artificial intelligence. So meant really to interact with the crew as a crew member.
It's like an intelligent advisor, part of the crew.
Absolutely, absolutely. So supporting in the daily routines and tasks, but more in a dialogue manner. So there's no limit to where artificial intelligence can be applied into our industry. The challenge, be it artificial intelligence, be it quantum, which indeed via a type of neural network approach can help training algorithms for artificial intelligence at unparalleled speed. The challenge for us is that at the end, the results need to be applicable to our products. So need to be certifiable according to airworthiness standards and requirement, right? And as of today, explainability of artificial intelligence, for instance, is a real challenge for us when it comes to certification of aircraft. And also, in the future, the results of quantum computing in a probabilistic sense will also need to be made compatible with the requirements of aviation. So this is the biggest technical challenge we see into really applying these incredibly really disruptive technologies to the certification of our products. And more in general, we strongly believe in the wisdom of the crowd out there, and we acknowledge the need to build bridges between industry and communities of experts, scientists, students, startups out there. And it is in this sense that we are launching the Airbus Quantum Computing Challenge officially today, and we're reaching out to the community of enthusiasts out there to really join forces with the industry for a new quantum era in aviation. We're putting out 5 problem statements typical to our industry of different degrees of complexity, so going for very simple mathematical problems to very complex challenges around flight physics. Like, for instance, the optimization of a wing box design. It's a very complex engineering component of an aircraft where many, many parameters, many disciplines put out requirements to be fulfilled coherently and concurrently, where quantum is absolutely the natural solution.
We heard it here first, the Airbus Quantum Computing Challenge. It launched today.
Launched today, absolutely.
Anybody in the audience can participate.
Anybody. It's open to everyone, so it's on our site, airbus.com, under innovation. And we already have a lot of interest, much more than we thought we would, because we know there's not Richard Feynman, which was mentioned in the IBM speech, won the Nobel Prize in '64, but he was saying nobody really understands quantum computing, quantum technologies, and there's really a handful of experts out there which we're really looking to in order to really join forces, speak one voice with the industry, have the chance to interact with our experts, and really solve some very tangible problems in aviation.
Well, you get into an interesting issue there with kind of explainability and the understanding, and that's an area we've been focused on a lot across AI, quantum, and other technologies. And the fundamental word that I'd use is trust. When you look at the underlying way that these technologies are being used. And it's an area that I think is really important for anybody looking at these technologies to think about, because if you think about any of these technologies, without trust, you're not going to be able to engage your customer, your business partner. Without your customer or your business partner, you're not going to get any data. Without the data, there's no AI or quantum or anything else. So it's a circle. So I really think this starts with trust, and we need to build trust within our organizations and understanding these organizations, and trust with the business partners and consumers, which is why we've been really focused on this area of responsible innovation generally and responsible AI specifically in terms of new frameworks that we're working on to build that trust for organizations. I believe that any organization that doesn't have trust at the C-suite and board level as a key strategic objective will have a problem in this new age we're moving into, because it becomes a strategic differentiator. And that gets into explainability and transparency that you talked about. It gets into bias and understanding your data and how it's applied, what biases it may have, which AI and quantum will really accelerate if you don't deal with it the right way. And it gets into fairness and honesty and how you deal with applying the technology. So as our critical new issues, I think that quantum, AI, and all these technologies, and you get into biotech, it's even more so that this issue of trust and responsibility again becomes strategic top-level C-suite and board concern for companies.
Absolutely.
Do you agree with that?
Absolutely. So it's not only a matter of soft trust between people, respect, but really establishing this understanding. You don't need to be a scientist to understand the implications, how impactful these type of transformational technologies can be. So it's really our duty to make sure that we make it transparent, accessible, and understandable for everyone.
The Quantum Computing Challenge is great, because that's going to engage and bring more people in outside Airbus as well. Well, we're winding down here in the time, so before we run out of time, maybe we can end with a little bit of a prediction. So we talked about AI, quantum. Where do you think we're going to be in 2025? Look out, it's a long enough way where we won't hold you to it, but also an interesting time horizon where things will have changed a lot. What do you think will be? Where will we be, and what will be happening in 2025 with these technologies?
Well, artificial intelligence is happening today. It's already being deployed largely, and it's indeed a revolution. When it comes to quantum, we're taking it really step by step. wanting to demonstrate also step by step the potential of these amazing technologies, not only in computing, but also, as I mentioned, in sensing and communications. We're encouraged by the fact that there's huge investments. There's a European Quantum Flagship Program, where we as Airbus were participating to the high-level steering, and there's investments planned of like €1 billion over 10 years. So we really trust that that will help accelerating. We're looking at the industries worldwide, so not only at ours, because we believe that any progress achieved elsewhere will also be fundamental and key for us to leverage on. So we already see today some very tangible applications. I spoke about trajectory optimization and others. And I believe in 2 years, we could already see some tangible industrial applications in this sense.
That's great. No, good. And that means we have 20 minutes left, right? Is that
yes, that was my 20 minutes.
No, we'll wrap up. I'll just add my prediction real quick, which is, I think we'll see a lot of advance in the technology by 2025. I think the biggest change that we'll see is the interaction. If you have your iPad, and many of you are typing on your phones as we're talking. I don't think we'll be using iPads and phones in 2025. The iPhone and smartphone itself is only 10 years old, and 11 years old. I think it's a transitional technology, and we'll have this quantum computing, the AI, and the new forms of interaction are going to dramatically change the way we adapt and use technology. So smartphones gone in 2025 is my prediction. Anyway.
We're all free.
Okay. Well, continue the dialogue with us. We're on Twitter. We already started a little bit of a Twitter exchange. Find us at the conference. Continue the dialogue on Twitter. And thank you for the time. And
thank you very much for your attention.
Grazia,
it was great, Paul. Thanks.